As promised, here are the answers to the Common Assessment Review packet that we did on Friday. I'm going to go as quickly as I can, but I'm also going to answer each of the 30 questions, so if you're looking for an answer later in the packet, you might want to just fast forward until you see your question number come up. Alright, questions 1 through 3, reviewing Unit 1. Factor pairs come from that factor rainbow, or just thinking what times what would equal 36. So our factor pairs are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Factor pairs are limited. There's only a certain number, so once you've got them all, you're done. Multiples, you could have as many of those as you could possibly think of, and they are the answer to multiplying 36 times something. I really do recommend 36 times 1, 36 times 10, 36 times 100, 36 times 1,000, because those multiplication problems you can really just do by adding zeros onto the end. You don't even need to show your work, and that's a lot easier to do than trying to say 36 times 2, 36 times 3, and hoping that you didn't make a mistake. Alright, next problems. These are GEMDAS problems, so we got to start with our grouping. 2 plus 4, 6 plus 4 is 10, divided by 2, that big dot means times 5. Well, there are no exponents, so I'm going to move on to multiplying. Whatever I see first in my problem would be this right here, 2 plus 40, divided by 2 times 5. Multiplying and dividing again, whatever I see left to right, 2 plus 20 times 5. The 20 times 5 is 100, plus 2 should give us 102 for A. Don't forget, your exponents do not mean 2 times 3. It means that this problem is 3 times 5 plus 2 times 2 times 2. 3 times 5 is 15, plus 2 times 2 times 2 is 8, for a final answer of 23. For number 4, a square number is a number that would have an area model that makes a square. So for example, if I drew out my square and I had side lengths of 1 and 1, the area of that square is a square number. Side lengths of 2 and 2, 4, the area of that square is another whole number or square number. 5 side lengths of 3 and 3, 9 is a square number, and on and on and on. So you're looking for one of these answer choices where you could say this equals a number times itself. The answer would be A, because 8 times 8 is 64. Here's a hint that I want everyone to be able to think about when you think about prime factorization. It can only be multiplied together prime numbers. So automatically, knowing that, I can eliminate G, because 10 is a composite number. So even though that might multiply up to 120, it's not going to be my answer because it's not a list of only prime numbers being multiplied together. 6 is also composite, so H is out. At that point, I do need to multiply my options together. Hopefully just multiplying one of them will either tell me it's right and that's it, or it's wrong and it must be the other one. So let's try J. 2 to the power of 3 is 2 times 2 times 2, which is 8, times 3 times 5. 8 times 3 is 24, times 5. Well, here's my times 5 trick. I would go up and say 8 times 10 is 240, but that is half as much as, or that's twice as much as what I actually wanted, so I'm going to divide by 2, 120. J is my answer. The sum of 1 to the power of 1. 1 to the power of 1 means 1 times itself one time, which is just 1. Plus 2 to the power of 2, plus 3 to the power of 3. So 1 plus 4 plus 27 equals 32. Number 7. Prime factorization, again, only prime numbers. 165 is composite, so I'm going to eliminate any answer choice that had 3 in it. This exponent right here means that that actually equals 3 times 5 times 5 times 11, which is the same thing as 1. So, without even having to multiply it, I realize it must have to be j. Another GEMDAS problem, this one with integers. I'm going to multiply first. 12 times 2 is 24. A positive times a negative is going to give me a negative answer. Plus 6 minus 22. Negative 24 plus 6. I can make a chart for 24 negatives, 6 positives. Well, negative team wins by 18 points. Negative 18 minus 22. When I have a subtraction problem, I'm going to do keep, change, opposite, which gives me a final answer of negative 40. All right, decimals in my division. I know that I want my divisor, the outside number, to be a whole number. So what I'm going to do is I'm going to slide that decimal one place to make it 15. If I do that, though, I have to slide on the inside the same number of times. My decimal is now after the 6. I'm going to raise it to the roof, put it right there. And now I'm looking at the problem 96 divided by 15. I can list my multiples of 15. 15 times 1, 15 times 2, 15 times 3, times 4, times 5, times 6. Ooh, look, that's real close. 6. With a remainder of 6, I can add a 0 after my decimal point and bring that down. Notice how I'm only adding it inside the house, not in my quotient. 1, 2, 3, 4. I have no remainder left. Oops, went too far. So my answer for 9 is 6 4/10. Number 10, Miss Castro went to the store this weekend to buy Halloween candy. She bought 5 bags of Snickers that each cost $3.79 and 6 bags of Twix that each cost $4.58. What's the total amount that she spent on candy? All right, I'm going to start with one of the problems. It doesn't matter which one. $4.58 times 6 would give me $27.42. Do not get tricked by answer choice A. This is only for part of the candy. This is only for Twix. I still have to add in the Snickers. So I'm going to do the same thing. I'm going to multiply $3.79 times 5. That gives me $18.95. Don't get confused by that being the answer choice for B. Then I have to add the cost of my Snickers and the cost of my Twix. So if I stack those up, I'm going to add them and get $46. So my answer choice should be D. All right, that ends the review for Unit 1 on factors and multiples. This next section is on both Units 2 and 3, fractions and decimals, starting with labeling things on a number line. I can see that this number line goes from 0 to 1, and there's 1 dash in the middle, so I know that's going to be 1/2. That triggers me to pretty quickly want to place my halves. So here's 1/2, 2 halves, 3 halves, 4 halves, 5 halves will go right here. 2/3 is not even 1 whole. If you're having trouble remembering where 2/3 would go, I like to think about it like this. Draw me a box. Shade in your 2/3. And if that's 0 and that's 1, 2/3 would be right about here. There are my two fractions taken care of. Let's see. I know that if this is a half, it's going to be 5/10. 17/100 is probably right about here. 43 thousandths is even smaller. So my answer should be that 2/3 is closest to 1 whole. Which of the following does not represent the same number as this? What I would do right away before I even look at my answer choices is say, well, if 84 is inside my house, it's going to be on top of my fraction, and it would be the first thing in a division sentence. And I would write out all my options and then go look at the answer choices, keeping in mind I'm looking for the one that doesn't represent it. Just starting with F. If this is what actually represents it, this is the opposite, which doesn't represent it, so there's my answer. Which statement is true? Oof. All right. So we've got some division sentences and some fractional representations of division. I like them in fraction form best. I'm going to take this right here and change it to a fraction. If it comes first, it goes on your numerator on top. If it comes second, it's in your denominator. All right, so now I'm going to ask myself, well, to get from 30 to 15, I'd have to divide by 2. If I divide 14 by 2, does that give me 8? No, it does not. That should have given me 7, so A is incorrect. 62 over 12. 62 divided by 2 equals 13. 12 divided by 2 equals 6, which is not what's over here, so B is also wrong. 4 divided by 28 is going to be less than 1 whole. It's not going to be 7. 28 divided by 4 would be 7, but that is also wrong. If I wanted to do 36/8 and try and change it to a mixed number or use the taxes method here, I could prove that D is my answer, or I could also just reason with myself and say, well, if I eliminated A, B, and C, D has got to be my answer. Greatest to least, this is the order we're looking for. All right, is 2500s greater than 3800s? No, it is not. Is 1 in 2500s greater than 1 in 1300s? Yes, it is. Is 1 in 1300s greater than 1 in 2800s? No, it is not. Is 2 in 5600s greater than 2 in 4400s? Yes. Is 2 in 4400s greater than 2 in 3500s? Yes. Is 2 in 3500s greater than 2 in 1600s? Yes. Is 2 in 1600s greater than 2 in 900s? It is. This is my answer. Let's just double check. This first one is bigger than the second one, but oh no, this is actually bigger than this one. D is wrong. Here's the tricky part of number 15. The fastest runner should have the smallest time, smallest, shortest, however you want to think about it. It should not be a big number if you're going to be fast. Looking at these four, the first thing I want to do is change that to 50 and 60 hundredths so that we can compare. Let me see, which one is the smallest of these? It looks like this right here is the smallest, so they would be the fastest, and actually only one list starts with it, so there we go, D. But also if this is my largest, I like to double check. Yes, my list does end with that. Sheila has 38 pictures and she wants to put 6 pictures on each page. Think it through. Does she want to divide up her pictures and put them on a page? Or does she want to divide up her page and put them on a picture? She wants to divide up her pictures, which means that the 38 should come first, and put them on the pages. So F is incorrect. That's dividing up pages. If I were to change this, 38 would be my numerator and 6 would be my denominator. Also wrong. If I then wanted to divide it, 38 would go in, not because it's bigger, but because it came first or on top, and 6 would go out. I really don't want to have to do this long division, so let me see if I can't simplify my fraction, since one of my other answer choices is a fraction form. Divide by 2, divide by 2. I did wind up where h was my answer. If you divided it out, this would give you 6 and 3/10 repeating, which is not the same thing as 6 and 5/10. Miss Beck has 2 cups of sugar, 1, 2, that she divides equally into 8 containers or 8 pieces. If I chop up each of these into 8 pieces, and I take one piece from here, that's going to be 1/8, and one piece from here, that's also 1/8, and add them together, that is 2/8, which simplifies to 1/4. My answer is D. 4 friends have to share 3 cookies. Do you want to cut up your friends and give them to cookies, or cut up your cookies and give them to friends? Hopefully you're not a murderer, so you'd rather cut up the cookies, which means that you are taking 3 cookies and splitting them up between 4 people, which in fraction form would look like this, meaning your answer is J. Alrighty, I'm going to end the video here and then create a second one, starting with number 19. Never mind, I couldn't figure out how to do that without giving up the rest of my work, so this is going to just be a very long video. Alright, here we've got common denominators already, which is excellent because for adding and subtracting I need them. You have 2 choices. You can regroup and borrow 1 whole and make this 3 and 5/5 plus 3/5 to represent this amount, minus 3 wholes and 4/5, which would be 3 and 8/5 minus 3 and 4/5, which gives you a final answer of 4/5. Your other option is to do the taxes method on both of them, making this 23/5 minus 19/5. That also gives you 4/5, so no matter how you chose to do that, you should be good. For number 20, Texas method is the only option here for both of them, because when you're multiplying or dividing fractions, you need to have just a fraction, not a mixed number. So this would be 35/5 times 8 times 2 is 16 plus 4 is 28. I would recommend simplifying before you multiply, because 20 times 35 just looks icky. 28 you could divide by 2 and have 10/4, which then again you can divide by 2 and have 5/2. 35/5 you can divide by 5 and get 7/1 times 5/2, which is a lot easier to say 35/2 than to multiply it all out and then simplify down. 35/2 is your answer here. I'm going to go ahead and cross off 22. I mentioned it in a few classes, but not all of them. That 54 just makes it really, really, really giant numbers. If you did it, great. We should have Texas methoded and then done keep, flip, change, but it was a huge multiplying problem, and it's not going to be something that's realistic for your test. This, however, is. When you're adding or subtracting, you need common denominators. So I'm going to do 6/8 times 5/5 is 30/40, and 3/5 times 8/8 equals 24/40. So I have 36 minus 24, that gives me 12/40, which I can simplify by 2, that gives me 6/20, which I can simplify by 2 again, which gives me 3/10. Ratio tables. We are looking for a common scale factor. 10 times 2 equals 20. So 2 times 2 would give us our answer here of 4. And 8 times 2 equals 16. From there, you can either go back and say 2 times 4 equals 8, or you can go from 4 to 8 and say 4 times 2. You will get the same answers. 20 times 2 is 40. 16 times 2 is 32. I can't get directly from 40 to 50 or from 20 to 50, so I'm going all the way back. 10 times 5 is 50. 8 times 5 is 40. 2 times 5 is 10. If the ratio of oranges to apples in Terrence's fridge is 2 to 9, first of all, don't put oranges in your fridge. That's going to dry them out. But for whatever reason Terrence did, 2 to 9, which one might be an equivalent ratio? Let's notice something first of all. 2 oranges to 9 apples. There are always going to be more apples no matter what you multiply by. So right away, I know that I could never be correct just because there are more oranges there. That means that I get to cross off answer choice A and answer choice D, which is real nice. All right, can you multiply 2 times something to equal 28? Why, yes, you can. 2 times 14. 9 times 14 is going to equal 126. Ooh, 2 works, which means automatically that if 2 works and C is 3 only, that's not going to work. You could also double check and say, can you multiply 2 times something to equal 11, which you can't. Not a whole number anyway. So B is our answer. The recipe for 40 dark chocolate truffles is shown below. One day Wendy has 16 cups of dark chocolate. Assuming Wendy has enough of her other ingredients, cream, how many truffles can she make? All right, so the original recipe is 40 total to 4 cups of chocolate. Now, we are saying that she has 16 cups of chocolate, and we want to know how many truffles she can make. Well, let's look for a scale factor between 4 and 16 times 4 times 4. She can make 160 chocolate truffles. At the bowling alley on Saturday, the ratio of females to males was 3 to 1. 3 females to 1 male. Ooh, total customers. Well, let's figure out if there are 3 females and 1 male, that means there are 4 total in this ratio. How many were female? All right, so the new ratio we want is that originally there were 3 females to 4 total. And now we want to know if there are 3 females to 4 total originally, and we have 116 total now. How many females are there? So we have to find our scale factor between 4 and 116. I don't know it off the top of my head, so here's how I can find it. 116 divided by 4. 4 goes into 1 0 times. It goes into 11 2 times. 11 minus 8 is 3. 4 goes into 36 9 times. There's no remainder, so that means my scale factor, fortunately, will be a whole number. 4 times 29 equals 116. So 3 times 29 is going to be 87. 87, don't forget your units, females. The table below shows the number of students who prefer a class subject. If Ms. Garza's homeroom has 30 students who prefer science, how many can we expect to prefer math? So we are saying that in Ms. Garza's homeroom, 30 students like science. Well, that is a 2 times 15 is your scale factor. So math, 3 times 15 is 45. Dario saw the following signs. This is a type of problem that's called a unit rate problem. We haven't learned about it yet this year. We'll learn about it when we come back from Thanksgiving break. But in case you did solve it, the way to solve it is to say that you have your money and you divide it by the total number of shirts that you have. So 42 divided by 7 means that each shirt costs $6 here. 30 divided by 5 means that each shirt costs $6 as well. And 21 divided by 3 equals $7 per shirt. So the question asks which brands have the same cost per shirt. Well, not 3, because that's more expensive. So not C, and not D, and not B. A says that 1 and 2 are the same, and it's just them. Okay, another ratio table. 4 times 2 is 8. 60 times 2 is 120. 60 times 3 is 180. So 4 times 3 gives us 12 right there. 4 times 5 equals 20. And 60 times 5 equals 300. We then have to take those points down and plot them. 60 and 4, 8 and 120, 12 and 180, and 20 and 300. Could I connect those in a straight line? Yes, I could. Should I connect them in a straight line? I'm not going to, because I would never want to find the point on my graph where I had less than one whole person. I'm okay with having less than one whole dollar, but I'm not okay with having less than one whole person. So I'm just going to check and see. Could I have done a straight line? Yep. Should I? No. Last page, last problems, also came from a ratio table. You can see I've got the first 3 filled out. This was a free response problem on a previous year's common assessment. So he's trying to fill up his pool with water, and the first thing that we have to do is fill in the rest of the ratio table. So I'm looking for 4. I'm going to go ahead and say 2 doubled, or times 2, is 4. 720 doubled, or times 2, but I'm going to use the doubling, is going to be 1,440. 4 plus 1 is 5, so I'm going to add the gallons that we had at 1 hour for 1,800. And then doubled that for 10 should be 18 times 2 is 36, right? 1,000. All right, there's my ratio table. Assuming the water continues to fill the pool at the same rate, fill out the missing parts of the table. Oh, yay, I did that. How many gallons will there be after 10 hours? I already figured that one out. 3,600 gallons. And if the pool has a total of 8,000 gallons, what percentage? We can ignore this one because we have not yet done percentage problems. Sorry that was a rush, but that is the answer key for your packet. Good luck on your common assessment on Monday.